The dirt on soil. This presentation, produced by the Henrico County, Virginia Cooperative Extension Office, covers Virginia Department of Education Landscaping 1 competencies, number 62, Analyze Soil Sample, number 63, Best Management Practices, number 64, Soil Amendments, Nursery Plants, and number 76, Amend Soil Based on Soil Analysis. It also covers Horticulture Sciences competency number 53, Characteristics of Soil and Soil as Substrates. Soil is so important for plant growth. It is the key to good growth for the plants, whether they are trees, shrubs, vegetables, or flowers. So you need to know your soil. This is where it all begins. Soil is important for a variety of reasons. First, it provides support for the plant. This is the area where the roots of the plant grow, and that helps support the growth of the top of the plant. Roots also are responsible for the uptake of water and nutrients, and then the vascular system of the plant transports this water and nutrients throughout the plant. The nutrients encourage green growth needed for photosynthesis and the flowers for seed production. So what makes soil good? First, soil needs to be loose and easy to work in. If it's compacted, those roots are going to have a hard time moving through that soil and getting established. Good soil also allows for deep root development. This allows the plant extra support and also allows the plant to withstand drought conditions by being able to have those roots further down where they can find water. Good soil also smells great. If your soil smells sour, there's something wrong with it. Good soil has that good earthy smell. Good soil is chocolate to brown in color and crumbly in texture. And it also has a lot of biotic life in it. Earthworms. This is a good sign of good, healthy soil. What exactly is soil? A desirable surface soil in good condition for plant growth contains approximately 50% solid material and 50% pore space. The pore spaces are the openings between the soil particles. Most of the soil solids are a mineral component, which is usually made up of many different kinds and sizes of particles, such as sand, silt, or clay. Under ideal or near ideal moisture conditions for growing plants, soil pore spaces contain about 25% air and 25% water. Since either air or water fills pore spaces, the amount of air in a soil at a particular time depends on the amount of water present in the pore spaces. Immediately after a rain, there is more water and less air in the pore spaces. Conversely, in dry periods, a soil contains more air and less water. Soil is naturally made up of several layers. Most soils have 4 distinct principal layers or horizons. Each layer can also have 2 or more subhorizons. The principal horizons that are collectively called the soil profile are the O or organic layer, A, the surface soil or topsoil, E, the subsurface, and B, the subsoil. The O horizon contains organic matter such as leaf litter and decaying plants. The A horizon, or the topsoil horizon, contains minerals at the surface that also show some organic matter enrichment. The E layer is a subsurface horizon that shows depletion of organic matter typically found in the A horizon. The B layer, the subsoil horizon, shows an enrichment of clay material, also iron, aluminum, and other organic compounds. Beneath the soil profile lies the C horizon, which is the parent material, and the R horizon, which is the bedrock, which is similar to that from which the soil was developed. Horizons usually differ in color, texture, consistency, and structure. In addition, there are usually considerable differences in the chemical characteristics or composition. Soil texture refers to the relative amounts of differently sized soil particles. For example, the percentage of sand, silt, and clay. Soil structure is the arrangement of the soil particles, the pore spaces, minerals, and organic matter that forms larger particles of different shapes and sizes. You can amend or change soil structure, but you cannot amend or change soil texture. This picture shows 5 different basic types of soil structure. The first is grainy. You can have either single grain or granular. Single grain is usually individual sand grains that are not held together. Granular are porous granulars that are held together by some organic matter and some clay. The next soil structure is platy. These soil aggregates have a thin vertical dimension with respect to a lateral dimension. Blocky soil is roughly equidimensional PEDs, which are usually higher in clay than other structural aggregates. Prismatic are structural aggregates that have a much greater vertical than lateral dimension. And massive has no definitive structure or shape and is usually very hard. Soil texture can be divided up into 4 different types based on particle size. Those include clay, silt, sand, and loam. So how do you know which you have in your yard or garden? If your soil is clay, it'll stick together in clumps. It will also feel smooth, and you can easily make a ball out of it that sticks together where you can play a game of catch. Your soil is silt if it feels like flour. And your soil is sandy if you can see and feel the individual grains and cannot, even when it's wet, make it stick together. Most gardens have soil that is a combination of these different soil textures, and this is called loam. So let's talk a little bit more about each of those textures. We'll start off with clay. Clay is the smallest soil texture. So when you hold your soil, does the soil stick together? Can you form a clump with it? Can you pack it and make it into a ball that you can throw? Also, clay is going to feel very smooth when you rub it between your thumb and your forefinger. You also may find gray or red mottles in your soil structure, and that indicates a clay component. Silt is the next largest soil texture. It fits in between clay and sand. When you rub your fingers together with this soil, does it feel like it's floury? Or does it have a slippery feel when you wet it? This is a soil that has silt in it. Our largest soil texture is sand. Can you see the individual grains of the sand in your soil? When you try to make a ball, does the soil stick together? If it crumbles apart, then most likely it has a large component of sand. Or if you rub it between your finger and forefinger and thumb, does it feel gritty? Those are the particles, those large particles of sand. Gardeners like a good loamy soil. A loamy soil is a mixture of all 3 of those soil textures, sand, silt, and clay. If a soil has a lot of sand in it, it might be called a sandy loam. If it has a lot of clay in it, it might be called a clayey loam. But what we want to see for a loamy soil is a soil that is kind of crumbly. When you pick it up and break it apart, the particles should kind of be like breaking up a piece of moist cake. You should also be able to make a ball out of it, although maybe not a really large ball. And you may be able to throw the ball, but the ball will break apart when it is caught. So other than the field test, how can you figure out your soil texture? One simple method is called the jar test. Take a jar, size does not matter, fill it approximately 1/3 with your soil that you want to be tested. Make sure there's no organic matter in there, sticks or roots or roots, and then fill the remainder of the jar with clean water, leaving a little space at the top. Add a drop or 2 of dishwashing detergent, put the lid on the jar, and shake vigorously. Place the jar on a table and leave for several hours. You'll start to see the components or the different textures of the soil settle out. In about 2 days, you can use a ruler and measure and record the height of each layer and then calculate the percentage of each of those components of sand, silt, or clay. You can then use the soil triangle or texture triangle to figure out what soil type you have. On the triangle, the clay percentages are listed on the left side. The lines corresponding to clay percentages extend from the percentages reading from the left to right. The silt percentage is on the right side of the triangle, with the lines extending downward or diagonally right to left. And the sand percentage is on the right side, with lines extending upward diagonally from right to left. Track those lines with the percentages that you measured from your jar, and where the 3 lines intersect, that is your soil texture. This slide shows a visualization of the jar method. You can see in the picture the different components of the soil settled out and form different layers. Again, measure the total amount of soil particles and then calculate the percentage of each of the different layers and use the soil triangle to figure out what your soil texture is. Another method is called the ribbon method. Take your soil, add some water to it, and make a ball. Gently toss the ball up. If the ball breaks, then it has sand in it. If it doesn't break, then what you want to do is make a ribbon out of it by pushing the soil out between the thumb and the forefinger. If the ribbon crumbles, then you have a sandy loam. If the ribbon is 2 inches or longer, then you have a clayey soil. A soil test will help you know what nutrients are in your soil and also determine the pH or acidity level of your soil. Soil tests do not test for nitrogen, as it typically does not stay stable in the soil. Doing a soil test will allow you to know which fertilizers and best management practices that you can use to grow your plants best. To collect an accurate soil sample for testing, you need to make sure that you have a representative sample. You want to collect your sample from at least 10 different areas. You're typically going to use a trowel and dig down about 4 to 6 inches. That's typically the root growing area of the soil. And you're going to place that sample into a clean plastic bucket. After you've gathered all 10 or more of your samples, you're going to mix that soil together to make a representative sample of your area. Place 1 cup of mixture in the soil sampling box that's provided by the soil testing lab at Virginia Tech. And then you're going to mail that soil sample off to our lab where it will be analyzed. After you collect your soil sample, you want to measure your area. It is important to know math for landscaping in order to calculate the amounts of products that you need to buy. Your soil sample results are going to give you fertilizer and possibly lime recommendations per square foot. So you need to calculate the square footage of that area. The easiest way to measure the square footage of an area is to turn your garden into different shapes and then calculate the square foot of each of the different shapes and add them together or subtract them out. So for example, we have a circle here in the middle of this slide. Maybe you have a tree in the middle of your lawn. So your lawn shape might be a rectangle, and you'll calculate the square footage of that rectangle, and then you'll calculate the square footage of the tree area, that's represented by the circle, and subtract that from your lawn area. And that will give you the square footage of your yard so that you can interpret the soil test results. This is a visualization of how you may divide a lawn into rough geometric shapes in order to calculate square footage. You can use geometry formulas for the shapes to do the math. For example, the square foot of a square is done by multiplying the length times the width. After you've collected your soil sample and placed them in the box, which is similar to what you see on the left, you'll need to complete your lab form. This form helps the lab to know what you have already added to your soil in the past, such as lime. It also tells the lab what crop you are planning to grow, such as vegetables, fruits, or lawns. The soil lab recommendations based on the results from the lab test will be different based on the different plant requirements. So telling them what plants you're growing will help you get the best recommendations. So how can you get a soil test kit? Well, first you can get a soil test kit form and sample box from the Extension office. You can also get them from any Henrico County public library. For each sample, again, make sure you get a good composite or aggregate sample of the soil you want tested, and make sure that you're following all the directions on the forms. Once you've collected it, take it to the post office and mail it to the soil lab at Virginia Tech. In a few weeks, you will get your soil test result back, which will look something like this. This is an example of a sample soil test. The soil test will give you the soil pH result. In this case, the soil pH is 5.6, and will also give you other results such as the amount of phosphorus, potassium, calcium, magnesium, zinc, manganese, copper, iron, and boron contained in your soil. The soil test does not measure nitrogen because nitrogen typically doesn't stay in a stable form in the soil and cannot be easily measured. You can see on the soil test results the indication of the crop intended to be grown. In this case, it is a cool season lawn containing either bluegrass or fescue, and it's lawn maintenance, not lawn establishment. You'll find fertilizer recommendations, again based on the amount of potassium and phosphorus contained in the soil. And then based on the pH and amounts of calcium and magnesium, you will get lime recommendations. We've mentioned soil pH several times already. And what exactly is the soil pH? The soil pH is the measure of the soil's alkalinity or acidity. It is important to know what the soil pH is because many nutrients become unavailable if the pH is not correct. So your soil may have the nutrients that a plant needs, but the pH may make it so that the plants are not able to access those nutrients. Lime will raise the soil pH, while sulfur will lower the soil pH. And it may need 100 pounds of lime per 1,000 square feet to raise the soil pH by 1 point. Most crops like a pH of 6.2 to 6.5. The soil pH is measured on a scale of 1 to 14. The lower the number, the more acidic the soil is. The higher the number, the more alkaline or basic the soil is. A neutral soil will have a pH of 7.0. Typically, a pH of between 6 and 7 is generally recommended for most plants. Some plants, such as azaleas, hollies, and blueberries, are going to prefer a lower pH. Lawns typically like a pH of about 6.2 to 6.5. This chart shows the availability of a nutrient based on the soil pH. So let's look at the first line there, nitrogen. You can see that at a pH of 4.0, that line is very thin. As we get towards the 6.0 to 7.0 area, that line gets very wide. And then as the pH gets higher, that line gets thin again. So if nitrogen is available for plants in the soil, if we have a low pH of around 4.0, it is bound up by that acidity of the soil and is not available for plants. So if you add more nitrogen to the soil, it's just going to get bound up by the pH and not be accessible to the plant. So this is why it's important to make sure that you get a soil test and know the pH level of your soil, because you can add more nutrients and they're still not going to be available. So you would need to adjust the pH to make those nutrients readily available for plants to use. So you got your soil test report back from the lab. Now what? You need to follow the recommendations given on the lab report to correct your soil's pH, whether that's adding lime to raise the pH or adding sulfur to lower the pH, as well as adding the recommended fertilizer and nutrients. Again, you're going to need to make sure that you know the square footage of the area that you're going to treat and have that measured. All soil amendments are recommended in terms of square feet. So again, you need to make sure that you calculate the square footage of that area. Soilless medias are growing medias that do not contain any soil. So while you may hear of somebody having potting soil, it's actually considered potting mix or potting media. There is usually a high percentage of peat with other components added to it, such as bark, vermiculite, perlite, or even coir, which is a coconut byproduct. These mediums are typically used in growing container production in greenhouses and nurseries. And when you are completing your soil test form, it is important to make sure that you do properly indicate what type of plant you are growing or want to grow, so that the results you get back from the soil lab will match the needs of those plants.